Cool. All right, so I'm happy to be here. I shipped a release like 35 minutes ago, so I'm sure that on a Friday afternoon, it was great. I'm sure everything is on fire at work right now, but they're in California, they can deal with it. So, F-strings, or how to F up your code base with Python3. So F-strings are formatted string literals. This was introduced in Python 3.6. You can read the full proposal. These slides, I'm sure Pat will distribute at some point afterwards, but the PEP enhancement proposal is 498, literal string interpolation. You can read the whole thing. It's very interesting. I'm going to give a very brief overview. It's not exhaustive as to what's actually in the PEP, but the parts that I think are interesting or useful. So we talk about string formatting. We think about there's a couple different ways to do it in Python 2 and in Python 3. So probably the oldest and most established way of formatting is the percent formatting. So you have a string with these little percent symbols that look a lot like printf. And then at the end of your string, you put percent, you put a tuple of the values that you want to substitute in the string, and then Python does that. So little indicators could mean, maybe substitute a string here, substitute an integer. So this is a little bit fragile because as you maybe add or remove different formatting specifiers from your string, the length of your tuple changes and everything goes crazy. So you end up with something that's not the right length or it's too long. And it's really just, if you're doing large documents or large strings like this, it's very, very fragile. So as an enhancement to that, there was string.format. So this is a method you can actually call in the string.format, in which you can actually put variable names in the specifier braces. So it uses braces rather than percent. So here we're saying name, age, and anniversary. And then you can actually do name substitution there. So if you need to do an additional evaluation, you can say like age is age plus 1, anniversary, whatever you want to do. And then also supports formatting, that sort of stuff. If you want to get really clever with it, you can use it with locals. So you can do the splat locals syntax, and that'll actually automatically substitute everything from your local scope and expand it into the string. So that's how we do it in Python 2 and Python 3 up to 3.5. So that way is kind of old and busted, and now we're going to talk about the new hotness. So Python 3.5, we have F-strings. So basically what that is, we take a string, we put an F in front of it, and then the substitution magically happens. What's pretty cool about this is inside of these braces, we can do actual name variables. We can also do arbitrary Python expressions. And then what's happening here with anniversary is we're actually getting an additional format specifier after anniversary. So you can do additional filters or specifications as to how you want that string to be populated. So some of the benefits, like I said, you can use arbitrary expressions. So we can say 2d8, and then that string actually gets formatted as 256. We can do all the normal sort of printf things that you would expect. So we can say after the colon here, we put our actual format specifier. So in this case, we're saying give it 2 fixed points of decimal. And then you can also use methods in conjunction with format specifiers. So here I'm saying name.lower. It's actually invoking that function, giving me a lowercase version of this string, and then centering it in a field of width 12 with underscores. Some other benefits, you can use this in your repr or your str functions, so the things that Python invokes in order to generate human readable strings for objects. So here I have a repr function that's just appending the first name and the age. Then if you call an f string on that object itself, you get the nice pretty string function. So if you want to get even fancier, you can use it with the format protocol, which is PEP3101. And so what that does, you can actually add a method to your object, underscore format, and give it a format specifier. And here your object can get an arbitrary format string and then determine what string it actually returns based off of that format specifier. So in this case, I'm saying if I see last comma first as my format specification, then I'm going to return last comma first. Otherwise, I'm going to return first last. So what that actually looks like when we execute it, so if we say F person, we get Fred Smith is 50. You can tell that I actually checked this very closely. So here, if I do a format specifier last comma first, I get last comma first, and that should be 50, but it's 42. Yeah, copy and paste. So another good example of where this would be used is for datetime. So if you have a datetime object, you can get a format specifier. you can actually fully specify anything you would pass to strf time and get the year, time, whatever you want, or if you just want the day of the week, you can pass that as the actual format specification string. So you can see where you could use that for some of your custom objects to basically create filters on how that object is actually represented as a string. It's very useful. So one question is it fast? Is it faster, or is it a huge performance penalty? So I ran it through time it. And so with the format strings, we're getting like 7-8 nanoseconds a loop, whereas the other two are 2 orders of magnitude slower than format strings. So it's actually substantially faster. I think there's some edge cases where it's not, and this is actually also a recent improvement. So, say what?
Did you run it 10 times more?
Oh yeah, time it just does that magically. This is a Python magic thing, and so depending on how long it takes on the first invocation, it determines how many invocations to do. So it's like trying to run for 5 seconds or something like that. And so since this one's 2 orders of magnitude faster, it ran an order of magnitude more times. So yeah, all that being said, it's fast. But I do believe that's recent. I'm not sure of the version exactly, 3.7.4-ish or something like that. So there are some gotchas, especially if you're doing like dictionary access in the string. You got to pay attention to which quotes you're using. So like if you can't use single quotes inside of an F string that you've defined with single quotes, that's a syntax error. You can use double quotes inside of a string with single quotes, or you can triple quote the whole thing and it'll work. So that's not terrible to keep in mind, and your editor will probably tell you if you're doing something horribly wrong. Also, like backslashes, if you're escaping strings, can be a bit tricky. Also, you can't use comments in your arbitrary expressions, but that's probably a good thing. Like if your expression is so large that it justifies a comment, that's probably something that you shouldn't be doing as part of your string formatting. So once PEP publishes this, these are all kind of references. Both the PEPs, this pyformat.info is a really great overview of all the different capabilities that the format protocol has in Python 3. The Python strf time thing is the one that I find myself referencing a whole bunch because I can never remember the exact incantation that I want. And there's a pretty solid blog post about just using F strings out in the wild. And I think that's about it. You ready to go F up your code base? Yeah. All right, any questions? Well, that was easy. Cool.
All right, Darwin, you're up.
Yeah. I forgot to say, if you're interested in working on robots, talk to me.
Cool Terminator robots, or like
Say what?
cool Terminator robots, or death robots?
That's 2.0. How about open source robots? That's all I got. Yeah, that's
Robots, absolutely. So, hi, my name is Darwin. I'm here to unite. Got wires everywhere, man.
Sorry.
It's fine. Hi, my name is Darwin. I'm here to talk to you tonight about importlib.metadata. It's a library that's been introduced in Python 3.8 and ported all the way back to Python 2.7.16. So an alternative title for this one was or Production and Packages, A Tale of Two Versions. Which kind of describes a little bit of the use case for this, because this seems a little bit abstract when you get into it, and you're probably going to be wondering, like I did, what am I ever going to use this for? And then realize that you probably spent about 2 weeks trying to fix something that this would have been the perfect solution for. So, who's this Darwin guy that's up here talking to you right now? Well, I'm a software engineer. I've got about 8 years of experience. Been working on full stack web applications, server administration, API, and systems architecture, and a whole lot of other stuff. I've mostly worked at small companies, startups, things like that. which if any of you have ever worked at small startups, you know you wear many, many, many hats. I do many hats. So a more important question though than who's the Darwin guy is what is import lib metadata? What is that? So it's a library, like I said, that was available in Python version 3.8 and newer. It was backported as import lib underscore metadata in Python 2.7.16 forward, so it is available in earlier versions of 3.0. What it does is it allows access to the metadata information from installed package resources. And it does replace and extend similar functionality that you'll find in the entry point API and the metadata API resources that are found in the package resources library. Now you might be saying, well, if it's there, why would we ever use this? Well, primarily because the new library focuses on condensing that functionality down, making it simpler, giving you access to a bunch of convenience functions, and then extending the function that's already there. So, okay, that's fine, but what's in it? Well, of course, we have access to our entry points, which are our console scripts, our distribution utility commands, our distribution utility setup keywords, your Python egg info for packages, and so on and so forth. You also have the distribution metadata, which includes Python version requirements, distribution version, author information, GitHub pages, stuff like that. You'll see it here in a minute. I have an example to show you guys. And then, of course, there are the convenience methods that I mentioned. You can call it .version, .dis, .requires, and it'll provide you with that information without having to dig through the entire metadata of the package. So how meta does metadata get? It gets so meta. So all metadata that's attached to a package that is discoverable via the distribution info or the egg info, which is defined by PEP566, it's returned via the metadata function. This includes some information that is returned by the other methods, like the convenience methods, including version, requires, and so on and so forth. So if you need a lot of this information, it's probably better to go ahead and just grab all of it and parse through it. Otherwise, if you just need one or two things, use the convenience methods. But in other words, it grabs all the metadata. So let's try this out, shall we? So over here, I've written up a small little Django application with an API backend that goes through, looks at our packages, and pulls them up. Right here, I've got Django pulled up. As we can see the name, we can see the version, and we can see all of the metadata that's attached to it. Now, you may be wondering, okay, well, how hard is that to implement? There you go. So right here, we're pulling the package name, which is straight from the package that we're sending to it to look up the information. We're pulling out the version from the version convenience method that's there. And then we're getting all of the metadata for it. We're iterating over the items here and just prettying them up because otherwise you get a very, very, very long array that basically doesn't treat it like normal key value pairs. Now, does this mean that it's a fix-all? You can just go in and grab metadata for all of your packages? Not at the moment. We do still have to go through and use package util to iterate over the modules. So if you've ever done that before, that's going to be familiar to you, but you can go through, you can do that, and then you can pull all the information that you need from those packages. And like I said, pipe it out to an API. That's all of the packages and all of the metadata that we have for this small little distribution that we've spun up. So now you might be thinking, okay, that's cool. Where am I actually going to use that though? Like what would be my use case for it? Well, here's a good use case for it. You have a production server. It's an old legacy production server. You give it an update, just patch it. Newer version of Python, like we all should be doing at this point. We don't all do this, but we should. And you update the dependencies that are needed in the package, and you spin it up, load up your page, and all of a sudden you've got 500 errors everywhere. Why? Look at it, and it's saying that, hey, this method that was introduced in the new package, it's missing. Why is it missing? You know that it's there. Okay, well, let's log in, let's load up our virtual environment, let's pip freeze, and yeah, sure enough, all the packages that are running are correct. Well, you pull this out on your production server, you hit that API endpoint, you find out, oh look, that crispy forms package that's supposed to lay out, all these forms nice and fancy on this web page that somebody put back in 2014 that you were supposed to get upgraded to 0.8 is still sitting at 0.2. And you find out, hey, that's because of a bad WSGI configuration. So trust me, this will help you. About 5 minutes of time to dig into it, figure that out, and fix the problem. Unlike 2 weeks of banging your head against the desk. But yeah. So all of this is available online. I do have the small library that's available on my GitHub repository, and these slides will be made available online in the near future as well. If you want it, the good thing is it's in a Docker container. You can spin it up really, really quick, get it up, test it out. All the endpoints are already laid out for you, and if you can't remember them from the README, don't worry, there's a help function in there to print them out for you. So that's import lib.metadata. Anybody have any questions? I figured no. Come on, surprise me though. Nope, okay. Well, that's import. Yes?
I got one thing to add. So I was using Python 2.7 this week, and I know that's terrible.
No, trust me. Trust me. It's quite all right. I know the feeling. We're behind in production, and I'm still trying that Python3 migration push.
So one thing that bit me is that a lot of packages are becoming incompatible with Python 2.7, which is, I guess, a good thing. But if you're running an old version of pip, it doesn't always know to go and look in the metadata for like the Python version compatibility. And so I was pip installing things that were just breaking everything. So. All that to say, when you're doing this, I'm thinking about metadata, and that it's good to have later versions of pip if you wanted to treat the metadata correctly.
Yes. Yeah. Okay. Anything else? All right. Awesome. Thanks, guys.
Good evening, everybody. My name is Chris Hodges. I'd like to thank whoever brought the cookies. They're amazing. So my lightning talk will not be about Python 2, but will instead be about the Walrus operator in Python 3. My condolences to the other person who wanted to do this lightning talk, but...
How could you?
I've been looking forward to giving this talk for a while now. Let's see. I'm going to present, which is here. Am I good? Okay, excellent. Okay, so assignment expressions in Python 3.8. This is a fairly new addition to Python, hot off the presses, and it's also known as the Walrus operator. PEP 572 is the PEP this was introduced in. Preparing for this talk gave me an extra appreciation for PEPs in general. I didn't even know what PEP stood for up to this point, which is Python Enhancement Proposal. Yes, thank you. And so this PEP was very long, but it was a very helpful source for this presentation. So this thing's only been around since December in the released version of Python, and in a nutshell provides a way to assign variables within an expression. And it introduces a new operator in order to do that. It's been mega controversial, like super controversial. Now, I don't know if, I think everybody in here is old enough to know who Michael Jackson is, but this happened in 2002 where he held his child over a balcony, and this was controversial even for Michael Jackson fans at the time. So you know you've gotten to a point of controversy when you have an action figure made out of whatever you have done. This action figure is actually for sale on eBay right now for $900. Just random side note. I say all that to say, the controversy here was just over the top. It's one of the most controversial things that's happened in a Python pip, and it was just kind of interesting to research into that. So Operators available to us in Python 3.8. This is the full list. Operators have not changed very much in the course of the history of the Python language. One that was interesting that I realized had been added somewhat recently is this at, which is for like matrix multiplication. Since I don't do a lot of data science stuff, I didn't even know about that. But the new one that's added is the Walrus. And as you can see, if you turn the Walrus sideways and you've got eyes and tusks, that's kind of where the name comes from. Okay, so I thought I'd start off, this is just really basic, so bear with me if you've been doing Python for a long time, but I found it kind of helpful to get kind of a grasp on some of the nuts and bolts of Python as far as statements versus expressions. So a statement is, I've got some examples here. There's, I don't know, like 10, 15 different types of them. But they are more like control-oriented, right? Things that you wouldn't really be allowed to have on the right-hand side of an assignment, for example. And then expressions are things that evaluate to a value. And so Bob, just by itself, is an expression. It's a literal, right? And I learned that there's a term called atom to represent the parts of an expression. So an example of an atom could be a literal or a variable, for example. And so, all right, the music's kicked up. Fantastic. Excellent.
This is as loud as Mike's going to go, so I have to be a little loud.
Oh, that's good. That's good. I don't mind being loud. Let me finish that beer real quick. No.
You can't hear, just move forward closer.
So expressions can also be a lambda, for example. This would return a value that's a function. And then, you know, this is kind of a ternary thing, so you've got a kind of an if-else thing going on there, which is going to return a value. And then even even function calls end up returning a value, so this would be an expression as well. MyDict.sort returns a none, but these are all things that you could put on the right-hand side of a statement. All right, so we talked statements versus expressions. Let's go into the Python3 formal definition of the assignment expression. In most contexts where arbitrary Python expressions can be used, a named expression can appear. This is in the form of name, Walrus operator, expression, where expression is any valid Python expression other than an unparenthesized tuple, and name is an identifier. So really, the way I've started to think about it is you can say, I've seen you can take the operator and substitute the word becomes in there, and that's kind of a good way to think about it. So if I'm assigning something like, in this case, name would become the expression. And you're doing two things. You're both writing to the value, so there's a side effect, and that the target that's assigned is being written to that thing, and so you're evaluating the expression, and it's kind of this both read and write thing at the same time. One nice thing about this and having a separate operator for this is I don't know how many of you have done C programming in the past. This is a really frustrating problem when you're working in that language. You know, like, it doesn't matter how much experience you have doing it, like, sometimes you're just going to forget an equals, and it can be really hard to figure out what's going on. In C, what would happen is this printf would never ever execute regardless of what value I is, because false will be assigned to I, and then the if is going to look at the value of I to know, you know, what to do there. So, having been bit by that in the past, Python is much nicer about not letting you get into that kind of thing, even with the Walrus operator being added. So let's just look at a simple example of the Walrus operator. The PEP has numerous examples of where they have used the Walrus operator in Python core to improve existing code. So here's an example where we're getting an environment variable, Python user base, and if it doesn't exist, we do none. And you know, in previous versions of Python, you had to check to see if that thing was, you know, truthy or not, does it exist, and then return it. And then post-Walrus operator, we can both get the thing and check to see if it's truthy or not, all in one line. So that drops us down, a line. It's a little more readable, and so we'll expand from here. There's other ways where it can look even nicer. Scope assignment. This is where things, if the scope assignment wasn't part of this proposal, I don't think it would have been as controversial, but they do some interesting things with scope. Most of the time, the scope is just kind of how you would expect. So here, we've got a function Bob check. If it's true, we print Bob. So I can see Bob from inside of that if, I can see it from outside of that if, and I cannot see it outside of that function. So that's just kind of normal stuff there. Now, where things get interesting is when we start doing list comprehension, dictionary comprehension, those kind of things. The Walrus operator will kind of break out the target of the Walrus operator into the surrounding scope. So here's an example here of kind of witnessing something that's going on. So we have an any statement here, which is gonna basically loop through all the lines and lines and look for any line that starts with kind of a hash. And so the first one it finds, we're gonna see comment get that value, and it's gonna come out and say that the first comment is comment. And so normally you wouldn't really have access to any of that that's in that for comprehension. It would be hard. It would take a lot more lines of code to do that than what we've got here. And so comment comes out of that for comprehension and lets us kind of see what was the first place where there was a hash at the beginning of a line. So you can also use it to update state during comprehension. So here we're just doing kind of a running total for all the v values and values. We run through that and we're just kind of incrementing over it. This example was in the PEP and I was a little confused because it's much less, you can do the same thing with just the sum function, but I'm like, okay, well, they're just showing us that you can kind of keep track of a mutable state as you're going through a list. Let's see. So here is another example which I thought really kind of showed the Walrus operator cleaning up some code. So over here we've got a while true, and he's going to come and just read one line at a time and do some regular expression matching on it. Over here we have while line, and he just goes ahead and reads the line as part of the while, so he'll stop as soon as he finds that, when he's reached the end. And instead of having to do all this kind of what I call defensive programming of checking for null things, they're able to just go right in and just really break down several lines at a time and make this a lot more readable. So the thing about the Walrus operator is there's nothing new that it introduces. It makes it where you can do things with fewer lines of code, but as far as functionality, it's the same Python that's always been there. It's just now you can do things a little less verbosely. Let's talk about how not to use the Walrus operator. Very intentionally, they made it where you could not just use it at the top level. You can't just use it in place of the assignment operator. So if I was going to do this kind of thing, I would have to do equals here instead of the Walrus operator. This won't work. They do provide you a way out that you can surround things with parentheses, and then that'll magically work. It's valid, but it's not recommended. So similarly here, if you're on the right-hand side of an assignment operator, they also don't want you kind of doing Walrus operator things over there. It's just kind of discouraged. I thought this was an interesting example with a lambda function. You have to kind of be careful inside of lambda functions to use parentheses. So here they're, going through and matching. You would pass in a line and then it would check to see if that pattern matched and, see if there was if the second grouping of that pattern was there. Let's see, let's cover up that. And so the Walrus here is the M, sorry. And just cover my lineup. Let's see. So here, M Walrus operator, readout match. So it's able to look at that M, further on in the language expressions. So let's see. What kind of impact does this have on Python? Wow. I mean, it was just really amazing. So Guido van Rossum was the, I hope I'm saying his name correctly, Python creator, and the, let's see if I can get this right, and you'll help me if I'm wrong, benevolent dictator for life. That was news to me. So he was a creator of Python, been working on it since 1990, and PEP572 was the straw that broke Camel's back. I think he'd been looking to get out of Python maintenance for a while, but now that PEP572 is done, I don't ever want to have to fight so hard for a PEP and find that so many people despise my decisions. I would like to remove myself entirely from the decision process. I'll still be here, but I'm trying to let you all figure something out for yourselves. I'm tired and need a very long break. It's like, wow. So what happens to Python going forward? I figured that was important. I wanted to know, how is Python health doing? So another PEP 8016, defined a steering council, which 5 members would be elected by the Python core team on each Python feature release. The last election was in December, coinciding with a Python 3.8 release. So Python's still in good hands, and he's, is still kind of working in the background, but he's not on the steering committee or steering council. Anyway, that's all I had for Walrus operator. Any questions?
Yeah. What were the objections to this? What's so bad about that?
So in the PEP, there were 7 different rejected alternatives they had. So a lot of people had different ideas for what the Walrus operator, there was different ideas for that. There was a lot of controversy over the assignment data for list comprehension. All the lists that are out there, I can't remember the names of it, Python ideas or something, these lists were just blowing up, and it was just really hard for them to get the PEP through, just because everybody had really, really strong opinions on different pieces of it. It gave me a new appreciation for how hard it is to add something syntactically significant to a language that's been around as long as Python, and just how that affects all the other different parts of the language.
I mean, were the objections that something like breaking up scope like that, does that have performance, or is that part of it? Or is it just aesthetic language?
Sometimes the arguments were we're going to have to go down into the C Python and make changes down there, and it just being more complex than the benefit that it gave. I don't know. There was the scope thing was one of the bigger ones, and people they would try to take polls of people to see what do you want, and then
some selection bias is supposed to be.
Every time that door opens,
Yeah, another question?
Is some operator in itself an expression? Let's say expression. That whole statement.
I really wish I could hear right now.
There's source country, I guess. Only can handle it. But is the some operator itself an expression, or is it contract with parentheses and becomes expression?
Let's see. I got some, it helps me sometimes to see. So here, and I'm just showing that it just makes it much simpler. Some would be an expression because what comes back is a value. Yeah.
Expression on the side effect.
Yeah.
So it's what C does.
Last call? Oh, sorry. Hey.
I assume that since it's declared in the same scope, you have above, the internal, say, if statement, there's no impact on memory consumption, is there? It's the same as it was before.
Yeah. I wouldn't think it would impact memory. Was there another question? Or are you just trying to get my attention? Okay.
We're in shouting mode now, unfortunately.
All right. Anything else? Thank you, Pat. Thanks for hosting.
I'm gonna try to be very loud to overcome the country. Can you guys hear me? Think you'll be able to hear me if I speak this loud? Oh yeah. Even louder. We'll see when they start rocking. Let me get mine up. Yeah, I should be able to talk over that.
You got this.
Yeah. I'm even loud without a mic.
You need some control. I can talk over that.
It's just a challenge. So, is that font size okay for those of you in the back? Alright. So, I want to talk about my name's Viafore. I work at Canonical. I work on the Ubuntu operating system, which is a lot of fun. I'm not going to talk about anything Ubuntu though, other than that's what I'm running. I'm going to talk about a few different syntax operations that are new to Python 3. Someone's mentioned matrix multiply already. I'm going to talk a little bit about that. I'm going to talk about some new things that the asterisk can do for you in Python, and one new thing the slash can do for you that's new in Python. So let's start off with matrix multiplication operator. Who here has seen matrix multiplication operator before today? Fair. Who knows how to add your own matrix multiplication operator to a class? Good. You're gonna, yeah, you see in the background. Yeah, transparent terminals. All right, so let's get started. I have my own file where I've just created a class that multiplies everything you give to it. So it multiplies everything. I want to multiply everything by 2. So this is an object I've defined, and I can do this. I have a value in here, and if I do me plus 5, it's actually going to multiply that 5 by 2.
What's the value of it? You got that off the edge of the screen there.
Oh, no. Oh, okay. I can't see that screen. Hold on. Let's go off.
You can just tell us what trust you.
It's 0. Better?
Yeah.
All right. So I have this me equals multiplies everything. I give it a factor of 2. The value starts at 0. When I do me plus 5, I want it to become 10. 5 times 2. So whatever I add to it, I want to double. Whatever I subtract from it, double. So I subtracted 6 instead of 3. It's a contrived class, I know. I have an object and I'm doing arithmetic operations on it. In order to achieve that, I have this class right here, is what I've written, and it has a constructor, creates a value and a factor, which is passing through the constructor. I have a dunder add. Dunder is for double underscore. So when you define dunder add on a class, it gives you the plus sign on that object. If I do dunder sub, I get the minus sign. And so the Python interpreter is smart enough to know is that, hey, when I do a plus or a minus, I'm going to look to see if you have a dunder add or dunder sub method. There are dunder methods for string formatting. I know in Michael's talk we had dunder format. There's dunder for like mod. For every operator you can think of, less than, greater than, equals to, or comparison, equals, there is a dunder method. I'm going to show you dunder mat mul, or matrix multiply. Nothing to my knowledge in the actual core library uses this, but things like NumPy use this for matrix multiplication. Of course, I'm not going to use it for matrix multiplication. I'm just going to use it to change a factor just to show that you can use it for anything. So I can do me, the @ sign is the matrix multiplication operator. I really wish they didn't call it matrix multiply because it implies it can only be used for matrix multiplication. You can use it for whatever you want should you write it into your class. So this changes the factor I multiply things by. So if I do me plus 5, I should be adding 15. And 3 times 5. And 4 plus 15 is 19. Should you be doing this on all of your classes? No, please don't. Please, please don't. But if you ever are writing something where an @ sign makes sense, I don't know of anything besides matrix multiplication where it really does, but maybe you have something, this is how you do it. So that's one new operator in Python 3. I don't remember which version that was added onto, I think 3.5. I'm getting confirmation from the audience, my ego is boosted. All right, let's move on to some other operators. So let's talk about Python 2, boo. I'm going to create a function called foo. Has anyone seen this syntax before, or star nums? So what this does is it collects every argument you pass into a function into a list. Or I'm sorry, into a tuple, I should say, which is an immutable sequence. So if I call foo on 1, 2, 3, the nums variable is 1, 2, 3. It's in a tuple. And what I can do with that is I can say, you know, foo of 1, foo of empty, foo of 1, 2, 3, 4, 5, any number of arguments. It's fantastic. What? Question?
Yeah, just out of curiosity, a tuple that only has one value, has a comma after it.
Yes, that is it.
Standard.
If a tuple has one value, you'll see it with a comma after it to differentiate itself from a parenthesized expression. Like, this is not a tuple. This is not a tuple. That's just an expression. Putting that comma tells the Python interpreter, okay, that's a tuple. So there's this star operator that is present in 2.7. What's nice there is let's say I have a list. So my list equals 1, 2, 3, 4. Let's put that actually in a list because that's important. I can do things like I can do star to expand that list. So if I do through my list, I'm expanding that list into the arguments. So if you ever have a list of things and you want it to become arguments, I'm just trying to think of a good function. Who knows a function that takes like 1 or 2 arguments?
Yeah.
Pow? Do pow.
Can you expand dictionaries?
I'll get to that. Yes, you can. So let's say I have this pow42, which gives me 4 squared. I could technically say my list equals 4, 2. Maybe you got it in list format. I can do pow my list with that star, and it still works. So it's a way of converting lists to arguments and back. Now this star got a lot more powerful. So there's also a double star. So if I define a function, I say nums, and I'm going to say keyword args, quarks. I'm going to print my nums, print my quarks. So who is familiar with quarks? A fair number of you. So if I say foo 1, 2, 3, I get nothing for my quarks. If I start doing keyword args, so if I say x equals 4, y equals 5, I have 1, 2, 3 as my args, and a dictionary giving me my keyword value pairs that I pass in up here. This is all possible in Python 2. You mentioned dictionaries. I'm going to jump ahead right to there. You can actually do, so d equals x 4, y 5. I can actually do foo 1, 2, 3, and I do the double star to expand that. D, and it still works. What's really cool is I can actually say like x equal, or I'm going to do d2 equals a3, and I can actually expand right into there. So D2 now just got everything from D1. That's really nice. So let's talk about those function arguments again, what Python 3 brings to the table. There are times, question?
I'm sorry. So if D had A in it, and D2 had A in it, how would that explain?
I don't remember. Let's find out. So let's say X. Looks like it overwrites it. I don't know if that happens all the time. I would encourage you to
Latest one goes to
raise one.
So you do start RD and then X, and let them write it later.
So it's left right. And I'm guessing that's because.
Well, you said so it's left right. No, say X is 14 or something.
Yeah. Yeah. And I'm guessing that's because of. I'm just thinking like I think I can do this. Someone check me if I'm wrong. Like you can have the same key in dictionaries, and it takes the last one. I think that's the reason why underneath the hood. Don't quote me on it. People are nodding. Don't quote them on it either. I can't speak for them. Okay, back to Python 3. So what if I want only keyword arguments? You might be like, why would I only want keyword arguments? Let's say I have some AV control. Control AV function. There's lights and camera. And I'm not going to actually write anything for this. We're going to forget about it. If you are in your control base or your code base and you just see, God help you, what that means. Like, who has seen that in their code base? Like, what are these arguments? And you want a way to prevent people from writing arguments that way. So we're going to rewrite that function, and Python3 lets you say star. If you put the star in front there, and if I go run that again, there's an error. It takes 0 positional arguments. That's when you just pass arguments like you don't do. But 2 were given. I am forced to write the keyword args here. Lights and camera and action. It works. So you can restrict people to saying, I want keyword arguments only. That's really useful if you want to control. Like if you have 8 booleans in your function, first off, stop. That's horrible. But if some junior programmer 5 years ago wrote that and you have to live with it, you could restrict and say, all right, you have to pass this in through keywords because it's more readable coming in. In Python 3.8, they actually did something with the slash that it took me a while to realize why would you ever want that. So let's talk about it. Let's say I have my sum, and I want some numbers. I want at least 2 numbers, and I want any amount of numbers after. So I'm just saying maybe my sum always should have at least 2 numbers in my code base for some reason. And if I were to, let's just return the sum of first, now I can't code live, it turns out. Second, and then I'm just going to expand my nums into my list. So if I write my sum 1, 2, 3, 4, first is 1, second is 2, 3, 4, becomes a list for my nums, and 10, that works. But what if you start seeing people who write things like this? First equals 1, second equals 11. That doesn't make a whole lot of sense of like people depending on an implementation detail like that. What if I only want what if I want 3 things, or what if I want to change one of these variable names? It might be an implementation detail, and I don't want people to refer to them by keywords. So what you can do, I should say, if I leave anything out on here, it does complain because it is expecting a positional argument. I can say I want positional arguments only. And by doing that, I put a slash after as one of my arguments. Anything after that slash can be your star args or something like that. I could do a star args to pick things up here. You're saying don't take anything before the slash as a keyword argument. Sorry, this nums has to go after the slash. My bad. That bit me a bunch here. But let's just return my sum. So if I try to do that first second again, I got an error because it's disallowing keyword arguments. So you can control how people call your functions for readability purposes at your intent, and the runtime will catch that, slash them on the hand and say, please don't do that. It is confusing to the reader. That's just some using.
Because normally the positional arguments have to come first.
Normally the positional arguments have to.
So this is a way of overriding that?
No, it doesn't reverse that. It's saying I can't have first, second cannot be referred to by keyword arguments. If I had, I could have other. I could have other quarks in there. Let's actually print quarks and then return that sum. So I could still say my sum 1, 2, 3, 4, whatever equals 5, and that works. But I cannot use first and second as keyword arguments. It is disallowing me from saying, first equals or whatever. I have to keyword argument everything if I'm going to do anything. But it's saying, hey, I'm missing my positional arguments first and second, even though I pass them in through keywords. So it's just a really useful way of writing your functions, controlling how they can be called, which is a good thing. You don't want people to, the broader canvas you give a person to work with your API, the more ways they're going to find and depend on that you did not intend.
Can you press and then put just 2 last command, my sum for a second, but then put 2 numbers in front for first. Just any numbers.
So So because the positional arguments get picked up first, and then the rest are treated as qualities. So, one last thing I was going to show you, since we're talking about stars and they're cool. Iterable unpacking while we have La Bamba playing. Nice. It's not country, so I'm happy. So let's say I have my list equals 1, 2, 3, 4. Do I have any functional programmers in here? A little bit. Well, then you'll like this. You can actually do head tail equals my list. Head is the first value. Tail is a list of your remaining values. So you can actually, so if you don't know about unpacking, you can do things like A comma B equals 1 comma 2. A is 1, B is 2. You can do multiple assignments in one line. You can now put stars in Python 3, and at least you can put at most 1 star on that left-hand side here to capture as many arguments as it can as a list. So I can do, I have that head tail. Maybe I wanted to do first and tail. So now first is the first 3 elements and tail is my last element. So I have some text that says like name, path, age, 32, whatever. I could technically, or let's just say, and a bunch of optional stuff. I could say text.split, and what I can assign in there is I can say underscore, I don't care, name, underscore, age, and then just grab the rest. And I've just grabbed name and age out of that text without having to deal with what's the length of my string, what index am I in, any of that sort of stuff.
Never asked this to do bad programming things, but did you use this to avoid the too many values to unpack type issues?
Yes, probably.
Nobody can move this room live. I can't let anyone know about this.
You'd have to show me a snippet before I definitively say yes or no. But yeah, like,
all the situations I know where the scientists use this is bad.
Yeah, I found it really useful for like if I'm just splitting a list and like that string, just grabbing pieces of it, and there's a variable length thing I have to ignore in the front or the beginning. It's fine. You can even do. So I'm going to do A, B, C equals my list. And I can get the first, the last, and the middle pieces. And there are going to be like 3 or 4 like variables at either end of that. So it's really, if you have lists that you're just working with small pieces of, check out the star operator. So we've talked about matrix multiply, a few cases where star is really cool, and a slash. Any questions? This one up here, the text?
Yeah.
Okay, so underscore, I'm just saying ignore. So I'm text.split, will split by white space. So I have underscore name, underscore age, and the rest of this goes into that last underscore, which is this I don't care about. Yeah, so I grabbed out 2 fields from a variable length string with just a single handout.
Are you really 32 years old?
Yes. Yeah, I think. Yeah. All right. Any more questions about my age?
You didn't have to
No.
fortune in college, did you?
I did. I had to do a little bit of fortune.
So there's no way you can actually
I think you could probably print out that letter. Did you print that?
So in an interpreter, underscore is the, it actually bound to underscore. That will break your interpreter. Ooh, because normally underscore refers to the last value that you executed. That's dangerous, but yeah.
You might be confused that with rule, though, aren't you?
Now let's open up a new one.
Got weird rules about underscore.
1, 2, 3 plus 4, 5, 6, underscore is 579. But if you bind underscore to 23 and you do that same thing again, print out underscore, it overrides what the interpreter does. So don't do that in the interpreter. I was just showing this. I learned something.
Underscore for junk values.
Yeah, that's like reassigning a print function.
Underscore for junk values in your code base is an idiom that a lot of people will adopt. I encourage that. Just beware on the interpreter. So, do you want to give your talk or do you want to break or? Up to you. Yeah. Okay, so that's it for lightning talk. Another question.
Can you return the star operator?
I don't understand. Like over a list.
Now return age. I said return star list.
Let's do it.
Return service, pack the list and return it.
Yeah. I think we'll just return. So like you're talking about 1, 2, 3, 4, like that.
Yeah.
No. I mean, a lot of people think because I run a Python group that I know Python. Not really. I just go try things. Yeah. Okay. X equals.
No, and then I'm just setting the list and then return star X. No, just assign X and then return star X.
You really like this?
Yeah.
My advice, if you ever want to listen and have questions, go try it, because that's how you go learn all the fun stuff. We just went over the Walrus operator. That was Chris's talk.
Can you override the Walrus operator?
You might. Pretty good. No, I don't think you can. All right, so I think we're gonna break until 7:45. So if you have to use the restroom, grab a drink, grab some more food, go for it. We're gonna be giving away prizes. So we have a Humble Bundle, we have a JetBrains license to give away. You must be registered on our meetup to do that. Who here is their first time to a Python meetup here? Welcome, guys. Thank you for coming. If you want one of those prizes, I will be pulling from the meetup RSVP list, and I think it's still active. So if you were to sneak on in there and register, I'll just see a long list that I pick a random number from.
But the
Also-
Python cookies are for everyone.
Python cookies are for everyone. So 7:45, we're going to do this. 7:30 now, 7:45, we're going to do some of those prize giveaways. At 8, we're going to start trivia. Tickets for Pi Tennessee are on the line. So if you win in our trivia, you get a Pi Tennessee ticket.